Okay. All right. So now one of the reasons why this class idea came up is that when we talk about object-oriented design, object-oriented modeling, there are kind of two ways of looking at that. One is sort of a more object-centric focus. And there are situations where the focus is sort of on the objects themselves, but not so much on the classes. As you might guess, in Java and other kind of more production-oriented languages, including C++, C#, things like that, the emphasis is on classes and the types. This is one of the big differences between Java and JavaScript. The two have no relationship to each other except for they both have Java in the title. And they probably mentioned this. JavaScript, what happened was when Java hit the scene, it just kind of exploded. Everybody was it was like, the next big thing. I mean, it was overhyped, but there was still a lot to it. At the time, the dominant browser was something called Netscape. You can ask your grandparents about that. And they were developing a scripting language to work with that browser. It was called NetScript. But then Java was this big thing, and they said, oh, let's rebrand NetScript as JavaScript, because then people will think it's Java. So but as a language, it is, it's pretty awful. But as awful as it is, it's very powerful, and every browser supports it. So the reason why it's ubiquitous and the reason why we need to learn it and use it is because if you write something in JavaScript, then for a web-based application, then the user never has to install anything because every browser supports it. So as awful as the language is, it's ubiquitous, and so we're stuck with it. Anyway, I didn't mean to bash it too much, but the context is that the JavaScript approach to, because it's untyped, say, how do you deal with objects if you're not typed? Well, JavaScript's answer was to use basically template. You kind of create one and then you say, okay, I want more like this. But there's no concept of a type. See, a class is the type, and that's why the class concept is really the more important one for, again, we're talking about production level stuff here. If you're doing a web, something that's going to run in the browser, then JavaScript is the appropriate choice. If you're doing kind of more of a production level application, then something like Java is a better choice. Okay, so for today, we're going to look at enums a little bit more, and then using them as instance variables, kind of looking at, so far most of our methods have been setters and getters, but been sort of talking about behavior, so we're going to have a little behavior one. So if we haven't yet, being able to declare an enum, and I'm asking you to do that for the current assignment, declaring object instance variables, and then the other thing is that identifying which one needs to be exposed for reading and which for writing. Usually it's not a big deal to expose something for reading. It is a bigger deal for exposing something for writing, and that's something where I have a different opinion from some of the examples in the book. For example, in the course class that they were talking about, my perspective is that the name of a course is something which isn't going to be changing. Here's the idea, is that anything you expose to the public is something that is kind of meant to be invoked. So if you have a public setter method, then that means that that's something that can change. And so in my view, the name of a course is something that shouldn't be changed. And so there was no setter for that, unlike the book's example. So there's like a little bit of a difference. But it's not set in stone. You could make a case for making that a public setter. You might say, well, sometimes they change the name of a course. Okay, so you can make that case. But there are situations where we have variables that you don't even want to expose to anybody. It's completely internal. Okay, so enums. So when do we use when is an enum an appropriate thing? When you have a finite known list of sort of named things. We want to use these as a type, and you know all the ones that are possible and no more. In other words, what an enum does is it defines a set of specific finite objects, and you can't create any more of them. So why do that? Well, the alternative before this enum idea came about, if you wanted to represent something like that, the usual way of doing it was what's called the magic int. And the magic int is when you say, well, okay, we're gonna say, well, let's look at this particular example. And this is right here. Okay, we're gonna this is a taking the die class that the book has just a six-sided die, and say, well, is that the only kind of die that exists? And now I don't play Dungeons and Dragons. Anybody do? Yeah. So they're evident. There are 6 different types of dice that are used, and they have different numbers of sides depending on what If you want something with a probability of 1/8 of coming up, then a 6-sided die isn't going to cut it. You need, in this case, you have an 8-sided die. So, but there are these 6 types of dice that can be used, and it's kind of constrained by the kinds of solids that you can form that have kind of equal probability of each side coming up, something like that. But anyway, there are 6 having 4, 6, 8, 10, 12, and 20 sides. Now, before the enum thing, the way that this would be represented was with a magic int. And the magic int would say, okay, we're going to represent this as an integer. And if it's 0, it'll be the 4-sided. If it's 1, it's going to be the 6-sided. If it's going to be 2, etc. Okay, now, and that's the way, in fact, even in Java itself, which is, Java is written in C. And if you look at the source code, they have magic ints all over the place. Why? Because they were C programmers. And in C, you basically can't do anything else. So what's the problem with it? Well, the problem is that if I'm now going to, say, use one of these things, somewhere I need to set that int. And I need to make sure that that int has the right value. Now, as we've seen, if we're really careful using setters and stuff like that, we can kind of constrain it that way. But there's, in a large program, that can still raise the possibility of a bad value. So there's nothing to prevent a -1 being used as one of these things. If you try to do this in a large program, it'll kind of blow up. Okay, so instead, we can create an enum called die type. So here are the 6 types of dice, and this is what they're called. The 4-sided one is called D4, or I guess D for dungeons or dragons. I'm not sure which. Okay, so so how can we do that? Well, let's do that. Okay, let's first make sure that we're in sync with our GitLab. Okay. Now I'll put it in the main one here. So Java enum, I'll call it die type. I should really fix that. Okay, so, and it's just simply, oops, D4, D6, D8, D10, D12, oops, why are you doing this? And D20. What's the advantage of this? A couple of things. Well, one is now this is a type. This becomes a type. And so if I set this as a type somewhere, or if I have a method which requires one of these things, then these are the only values that I can give it. Unlike an int, which I can give it any legitimate int, these are the only values I can give it, or null. I mean, not the one little sort of issue now is that I can give a null, but at least in a magic int, the compiler will not pick up if I'm giving it a bad data. If I'm giving it an int that isn't the right value, that will become a runtime error if I catch it, but not a compile time error. Now, we haven't talked a lot about that, but it bears repeating, so I'll say it now and repeat it perhaps. Given the choice, well, like in a compiled language or a semi-compiled language like Java, there are two types of errors. There are compile time errors, which in NetBeans is the so-called red squiggly of death, and there are runtime errors. So a compile time error means that, there's something wrong with the syntax. And when there's something wrong with the syntax, there is zero chance of a program running. And you've heard me say this before, but it bears repeating, in interpreted languages like JavaScript, like Python, like any of the scripted languages that are interpreted, there's no compile time error, there are only runtime errors. And Murphy's Law says that your program's going to run for a while and then bomb out if there's a syntax error because it doesn't pick it up. So all syntax errors are picked up by the compiler. And given the choice, a syntax error is infinitely preferable to a runtime error. Because with a syntax error, you can't even run the program, you got to fix the syntax. So with the magic int, the compiler will never pick up giving it bad data. With an enum, the compiler will always pick up if I try to give something other than this enum in that context. Now the runtime, it's not all a bed of roses. I can accidentally give it a null, and that will result in null pointer exceptions, and those are runtime errors. However, the one good thing, if there is one, about null pointer exceptions, and you will encounter them if you write if you haven't already, you will. The one good thing about null pointer exceptions, and we'll get into this in more detail when we go into it, is that there is only one cause, and that is that you're trying to invoke a method on an object reference that has not been instantiated, that is null. If I try to invoke a method on a null reference, then what is it supposed to do? There's nothing to do. That is what will result in a null pointer exception. But there's only one cause of it. That means that variable is null. And so debugging that, I mean, it can be a little frustrating, but at least you know what the problem is. You know exactly what the problem is, and you know exactly where it is. So, and that's a big thing. Okay, so there's our enum, and we'll start using it in just a little bit. Okay. So, all right, so let's come back and talk about instance methods. So instance methods are associated with an object. So the Java has there's no function. A function is something that just exists on its own. So if I call a function, then I just call the function. There's no object, there's nothing else there. But an instance method, there's always, I invoke a method on an instance. The two have to go together. And in fact, the way to think of it is I'm sending a message to this object. And the message I'm sending is through this method. Even within the object itself, if I can call an instance method from another method of that object, and I don't have to explicitly invoke the object because it's always assumed to be that object. But I can always add the this to it. So it's just that's added under the hood. So setters, I say setters and getters, they have a very constrained functionality. So a getter just says it returns a value, and a setter just kind of sets a value. That's all it. So methods that are associated with behaviors, we want them to do more. Ultimately, that's what we want with our objects. So here, I want to create a die class that is going to model each of the possible ones in Dungeons and Dragons. And the die needs to know now, unlike the example in the book, which says it can only do a 6-sided die here. How many sides there are? Well, that's going to depend on which type I have. So the die needs to know how many sides it has and what type it is. So now the behavior, and this is the behavior. The behavior is I'm going to roll the die, die singular, dice plural. I'm going to roll it and then see what came up. And so I'll be able to also roll it a lot. So how do I do that? Well, by creating a class. And so my die class is going to have 3 instance variables. So first, because it could be one of these types, I give it an instance variable that says which type it is. It has, I'm going to have an instance variable that says what value is showing up on the die. And then in order to roll it, I'm going to need an instance of random. So I'm just going to have a 0 argument, oops. No, this shouldn't be a 0 argument constructor. This, that's incorrect. This, darn it. The argument here should be a die type. That was, I will correct that and upload the right one. So when I instantiate one of these, I'm going to give the die type in this, so that is incorrect. So now I'm going to get the face value, which is the current one, and then I want to know which type it is, and then I'm going to have a toString that's going to also give all of that. Here's the main instance method, though, is going to be this this roll method that'll kind of roll a new one. Now, this is we'll talk a little bit more about this, but this is an association of this is using something called composition, where I'm composing my die is composed of, it has a die type, and actually there could be another, just to be complete, there's also another class in Java, well it's in Java, but called random, and I'm also using one of those, so that's, to be complete, there would be something like that. Okay, so that's that, and so let's implement that. And then, now, how are we going to test it? Well, okay, yeah, first of all, none of my instance variables have setters. Like once I say it's going to be a certain die type, then that's what it's going to be. So we can actually declare them to be final. We actually don't have to, because if I don't have a setter and it's private, then it's essentially final. The random, see this random thing, see the type and the face value, that's something that I want someone to be able to see, but this variable is completely internal. I mean, that's kind of part of the guts of the thing. And so nobody needs to have any access to this whatsoever. And so now the other thing is that when we're writing, whenever you're developing things, you want to be testing them. In fact, ideally testing them as you go. So the ultimate test of this is one, I'm going to do two tests on this. One is I want to estimate the probabilities of each number, which I, essentially redoing the last assignment, but using this object. And then also just sort of another one is I want to estimate the average number of rolls until I get a 1, let's say. Okay, so let's kind of do that. So I want a Java class. I'll call it die. And actually, do this directly from the UML. So here again, I don't need to do any thinking whatsoever. And then, okay, red squiggly. Yeah, whenever you see a red squiggly, don't try to type anything more until you fix it. And when you hover on the red squiggly, it'll tell you what to do. And then sometimes, a lot of times, it'll be here as well. And then the little light bulbs are when NetBeans has an idea for you. And sometimes its ideas are kind of like clippies, and sometimes they're actually useful. So in this case, it says it can't find symbol. Whenever it says you can't find symbol, and you're referring to a class, a type, the solution is always to right-click and say Fix Imports. And one of two things, well, actually one of three things will happen. One is I may have fat-fingered the name of the class, in which case it says, it won't do anything. It'll still be red squigglied. That will usually indicate a typo. The second thing is what it just did. It said, oh, I found random. It's in Java util. I'll add the import statement. And remember, import doesn't import anything. All it does is it means I can refer to random using its unqualified name. And then the third thing is that it may find more than one on the class path. And if it finds more than one, it'll bring up a little pop-up and say, okay, I found 3 of these. Which one do you want? Okay. And then okay, so those are where did that come from? Those came directly from my UML diagram. So the name of the class is what I called it. The 3 instance variables were what I had directly from here. And now let's have the correct the correct one here. Okay, and I'm not going to finish it just yet, because what I want to do is I'm going to generate, say, refactor encapsulate fields. Now I want to be a little careful here. Okay, I want to expose face value and die type, but not the setters. And I check fields visibility is private. The accessor visibility, accessor is another word for setter getter. And for some reason, NetBeans by default puts them at the top, which I don't like, and I want to put it after all this. And so this is going to generate these. Okay, so first, I'm going to instantiate my random in my constructor to make sure that it's always instantiated. And now here's the thing, is that what is? Did I copy I copied the wrong thing? Darn it! This this actually should be. Okay, this actually isn't the face value. This is the number of sides. Drat. Okay, so now. Here's another little thing that this refactor thing is really good at. Now, in this case, face value only appears twice, and it also has a setter here. I want to change that. I want to change the name of that. The quote face value is actually, I want to have the number of sides. I don't know why I. So, two possibilities. One is I could change the name here and then go. I'll find all the red squigglies, or I can change them all at once with a couple of clicks, basically with a single click. So refactor, I choose refactor, rename. When you do it that way, okay, now look what happened. It changed it here. It changed it here. It should have also, play. It should have changed the, okay, it used to. It used to change the setter, but all right, so now that is really odd. It used to change that. Okay, so now I need to create the new setter. All right, as you encapsulate fields again, I want to get the setter. Let's do it as the last method. Okay. Something is off here. This is not behaving. All right. So now what I wanted to show you here is that, all right, I'm giving you a die type, but notice that the all the different types have different numbers, and they're actually sorry, I did this several different ways. Oh, okay. All right, I'll do it this way. Okay, now here I'm setting this in the constructor, but now I'm going to create a helper method, which is private and not exposed. Okay, so this really isn't a setter because it doesn't have an argument. But what I'm going to do is I'm going to do a switch on the die type, and pardon me? Oh, so I did. Okay, the meta lesson here is that kind of if you kind of sometimes struggle with this, you might notice that I struggle with it too. So it's like some of this is sometimes it's sort of deliberate, sometimes it's sort of not. Here I put the wrong UML diagram up. So, but I'm implementing it that I actually did it another way that showed something else. Maybe I'll show that when I do that. Okay, so okay, set the number of sides. So I'm going to switch on the die type. And just set them all by hand. And since I'm old school, was it D8 was the next one? Number of sides is 8. And this is where case D10. Number of sides is 10. D12, number of sides is 12. And 20, number of sides is 20. And I always want to default says why aren't you? There we go. What are you? Oh, yeah, you're unreachable. Okay. What are you? Okay. All right. So what's the idea here? Okay, I had a choice. I could have put all of this in the constructor, but that would have made the constructor this sort of big blob. Instead, now there's, for doing it this way, there's kind of there's no way around this. I gotta do something like this. And if I want to, I could convert it to one of these. That'll be a little bit cleaner. But nevertheless, even this is sort of a lot. Like ideally, you want your methods to be as small as possible, and so this way I can kind of see the constructor as kind of doing that. All right, the final piece is I want to write the roll thing. Okay, so, and I can just do this, I can take my random, and I get the next int from 1 to now, I get the one more than the number of sides. And, I noticed that's, a lot of you were kind of doing it the way the book does, which is just using the single argument. Nothing wrong with that. It adds kind of an extra little thing. Do you put the +1 inside or put the +1 outside? 6 of one, half dozen of the other. I prefer this, but yeah, that's just sort of a minor thing. All right. Now we want to kind of test this. And I think, let's see, we've pretty much done all that. So how can we test it? So our first test is to, oh, yeah, wait, forgot the toString. Okay, so this is going to tell me what type it is and how many sides it is, and just to kind of confirm that. So the first thing I want to do is just confirm. So let's make one of these just to. All right, now, okay, so I gave it the name of one of my enums, but it can't find it. So again, what is the solution? We fix our imports. In this case, it is sort of asking me to confirm that. And now notice that when I am importing the import statement for an enum is a static one. You don't have to worry at this point about that. But right now, the first thing I want to do is make sure what could go wrong. Well, maybe I screwed up the, yeah, in fact, actually, here's what I want to do on this. And I may have to finish this tomorrow, but enums, I can get every single enum there is, and I want to make sure that I haven't messed one of these up, okay, and there were 6 of them. So, there's a method called values in every enum that's created, and it returns an array of all the different possibilities of enums. So I'm going to create each one of these and then print it. Now this is where, how should I say, it's like this is where, in my view, the book kind of tends to not do this as cleanly as they can. You should always write a 2-string, almost always. Why? Because this is a lot cleaner. The other alternative would be to kind of keep typing this again and again. Now I just have to print the thing and just sort of make sure that I have all of them. So I see my D4 as 4, my D6 6, D8 8, D10 10, D12 12, D20 20. Okay, so I've confirmed that this is working correctly. And what are the kind of things that can go wrong? Well, one thing is I could forget to call that. That's something that that happens. And then and I look at this, and now they all have 0 sides. So they say, well, wait a minute, why do they have 0 sides? What happened? I go back and I say, well, it should have been calling this. Well, it didn't, so. Right, all kinds of things can go wrong. Or, what if here's another thing that can go wrong. I can forget to set this, and now I'm going to get an exception. So here's my null pointer exception. Which is all too easy to get. Okay, so let's kind of go back to our or you redo variable. Okay, so now notice a couple things here. Okay, why can I declare a variable of the same name here and here? Because of scope, exactly. The scope of this is within the for loop, and the scope of here is outside it. Is this the greatest style in the world? No, but this is a test method, and so like style is less important. That I'm just testing the thing. All right, so I want to do. Okay, let's maybe start with 1,000 or something. All right, so now I want to create my int. So I'm going to create my int, and now how do I know how big to make this? Well, I'm going to make it to get the number of sides. Okay, so there are going to be 4 sides. I want to test to make sure that the probabilities are working right. So I wrap now this in a, now this is what the, this is something where other languages have much, cleaner ways of doing something like this. But, okay, so, and okay, so I'm going to get, oops, die, roll, and, okay, so now which one do I want to put it in? Well, was it the roll count? Where's it called? Roll count. If I subtract 1 and just do that. And if you prefer the plus plus, then that's not the worst thing in the world. But then okay, now I want to, now whenever you're looping over an array, always use the length of the array as the upper bound. And the probability of, oops, I should, and watch out for integer divides. Okay, so so let's see if that worked. Okay, so here are the different probabilities on that, and if I want to bump this up, then I can basically do that. And they all more or less equal. All right, so what if, let's do it for 20. And in fact, if I wanted, I could sort of wrap all this up in this loop here and do it for all of them. But now, do you see how how should I say? It's like even within a testing method like this, you want to kind of use variables and stuff. So okay, so this is a way to, okay, what have I done? I've defined an enum here, and I'm using that enum in my method here, and this is similar to something else I'm asking you to do with your current assignment. So, okay, so now there are some sections in chapter 6 I'm skipping over. There's a lot of stuff about how to do things in Eclipse, so obviously we're not doing that. But now we're going to move ahead to sections 7.1, 7.2, well, chapter 7. Section 7.3 is this very extended, kind of cool application of this, but it's very complex, and so we're going to kind of skip over it and kind of do another one. So that's what's up for this